So like I said, in your notes package, I think this first one's on page 35, the next ones are on page 36 of your notes package. We're going to look at how we can do this with our calculator, and then how we would do it by hand, and how that's really nice for both of us. Okay? And if you don't have your own calculator, or your calculator doesn't let you do fractions, you're going to want to get one. Because sure, it's nice sometimes borrowing one from class, but sometimes you might borrow one and the next day you get a different version. It's really nice if you get used to your own version of calculator, because that's going to help you the most. So first of all, number one here, I'm going to take out my calculator, and we've got -7/3. It's in brackets. So your calculator, like I can put a bracket, I can put a fraction.
What page is this then?
Negative, I'm writing it, 35, 36. -7/3. Close that bracket. I'm writing it exactly as I see it, times by, and then another fraction, 6/5. So again, what you want to do with your scientific calculator is you want to have the ability to write it in as exactly as you see it, and then you can push enter, and we get -14/5. So I'm going to go to my notes right now, and on the left side here in green, I know that this is the answer. Now the next thing I'm going to do, this is going to be a nice thing on your test. I'm going to have a spot on your test where it's going to be like, what answer did you get with your calculator? Now show me the rest of the work. And what's going to be nice on your test, and not nice at the same time from a math teacher's perspective, is that on the one without your calculator, when you forgot your times table, things went bad. But with a calculator, if you forget your times table, you'll be able to check. So, this question, multiplying fractions. The rule for multiplying fractions is you multiply the tops, you multiply the numerators, and you multiply the bottoms, you multiply your denominators. So we can do that in this question. And if I multiply the tops, a -7 times a 6, -42. If I put the negative on the top, I don't also put it on the bottom. And the bottom is 3 times 5, which is 15. That's the rule for multiplying. Does it match the actual answer? No. Which means this can be simplified. And actually, having the calculator answer gives you a hint. What do we want our answer to be? We want our answer to be -14/5. What do you think you should divide the 15 by to get the 5? Close.
3.
Divide by 3, right? And so if I divide the bottom by 3, I should divide the top by 3. And probably in your head, mental math-wise, 42 divided by 3 is probably not something that comes really quick. But you have your calculator, so then you could go to your calculator and do 42 divided by 3, and sure enough, it's equal to 14. So we know our fraction rules, and sometimes knowing the answer gives us a hint of what we should do. And sure enough, I got the same answer here. Now I'm going to redo the first one. I'm going to rewrite -7/3 times by 6/5. And I'm going to ask if anybody remembers another way that we could do this that sometimes makes it easier. Divide what? Oh.
Oh, you can use that 6 and 3?
The 6, you can use the 6 and the 3. right? Because if there's something in a fraction up and down or diagonal that can simplify, so what can divide both 6 and 3?
3.
You can divide this one by 3, leaving you with 1. This one divided by 3 leaves you with 2. If you simplify early, then -7 times 2 gives me the -4. 1 times 5. I like simplifying early because that seems like a lot easier math than having to do the 42 divided by 3. But either way, you'd have your calculator, you can check that. Both are right. So we're going to do one more. Which one do you want to do, 2 or 3?
3.
3 looks more challenging? Okay, so first, we're going to take this on our calculator and type it in. So -5/4 in brackets. So I go bracket, take out my fraction button, -5/4. Take out my fraction button again. What was the other one? -2/3. So I write it exactly like I see it. I push enter, and it's supposed to be 5/6. So I'm going to go right beside that one, and I'm going to write 5/6. Circle it. That's what the answer is supposed to be. What's the rule for multiplying fractions? Multiply the tops, multiply the bottom. So if I did that, a -5 times a -2 is a +10. Do you remember that a negative times a negative is positive? And on the bottom, 4 times 3 is 12.
I have a question.
Yes.
Can you just do 4 and 2? Or can you do the
Simplifying?
Yeah.
I'll do that second. So if you just decided to do the rule, multiply the tops, multiply the bottoms, this is what you get. What do we want to get? We want to get 5/6. Can you see that's something you can divide both top and bottom by? Divide by 2. Divide by 2. Does it work? Yes. So we can use the answer to kind of, I don't know if it's cheating, but taking a hint, right? It's kind of, the answer kind of gives us a hint what to do. And what Brandon was asking there is, could I do, so I'm going to rewrite it in black. Here we go. -5/4 multiplied by and -2/3. And he's saying, couldn't I simplify the 4 and the 2? Absolutely. What divides both of them? You could divide them both by 2. If I divide this by 2, it would be a -1. If I divide this by 2, it would be 2. And then when I multiply across the tops, -5 times -1 is +5. 2 times 3, 6. And I get the same answer. So, there is a quick review of multiplying. If you had mixed numbers, you would change them to improper numbers first, and then do the same rules. Next, we're going to skip ahead. So in your notes package, I want you to turn to page 37. And we get the divide ones. Question is, do you remember the rule for dividing?
keep change flips.
Keep, change, flip. So if you're dividing fractions, you keep the first one. You change the sign to multiplying and flip the second one.
Other question.
Yes.
When 4 and 2 are across each other, they can both divide by 2. Can you do that?
No.
No?
You can only do that in multiplying.
Alright.
So we keep, change, flip. Now, is there anything on diagonals you can simplify? No. The 3's, you might be tempted by the bottoms, but they're both on the bottom. You would need one on the top and one on the bottom when you're multiplying.
So 8 of them.
So the best you can do is use 2 times 4, 8. Oh, we should, I got too quick, right? What was I doing? Calculator first to see what the answer should be. Because you just said a guess, but we're going to take out our calculator, and I've got my fraction button. 2 divided by 3, 2/3, hit the divide button, And on a calculator, have you noticed this? That sometimes you hit the divide button, it does a slash. That's just the calculator's way of writing divide. And then I do another fraction. And it was 3 over 4. And I push enter, and I'm supposed to get 8 over 9.
I have a question about that.
Yeah.
Will every calculator automatically keep change flip? Or
The
wait,
calculator, when you type it in,
Yeah.
does the right math. It's doing the keep change flip inside of itself and figuring it out. But that's why it's really important that you have your own calculator, because some have issues, right, with fractions. I think both of yours had like fraction issues. So that makes it a little bit hard. We want to make sure we get a calculator that allows us to do this as well. And 3 times 3 is 9. Let's do 1. This is on 1 improper fraction 1. This is on page 38. Which one do you want to do? 1 or 2?
page 38.
Page 38. 1? Okay. So I'm going to go to my calculator. And I've got my first one. Oh, it's supposed to be in brackets. So I might have to, oops. I'll put my bracket first. Bracket. And my first fraction was negative 3 and 1/5. So negative 3 and 1/5. Close that bracket. Divided by another bracket. Negative 2 3/4. So we have a good calculator that lets us type the fractions. We push enter, and it's supposed to be 64 over 55. So what I'm going to do is beside here, this is the answer that I want to get. How do we do this without a calculator? Well, first,
Yeah, change the improper fraction.
change it to improper fractions.
Wait,
So,
when you have it in the brackets, right?
Mhm.
And it's a proper fraction, whatever, right?
yeah,
Do you still flip it? Like,
we're going to change it to improper fractions first, and then for dividing, once we have that, we still have to do keep, change, flip. So we're going to look at the first one in brackets. 3 times 5
15,
plus 1
16.
as an improper fraction. That'll be 16 over 5. With the negative there, it's just negative 16 over 5. We still have our divide by sign. Second one, 2 times 4
8,
plus 3,
11.
11 over 4. Now we can do that keep, change, flip. We keep the first one, negative 16 over 5. Change the sign to multiply. Flip the next one. And now that you're multiplying, if you see anything on the diagonal you can simplify, you could. But there's nothing in this one. Mm-hmm.
So we turn the mixed number
We turn both mixed numbers into improper fractions.
after we get our answer, would we not turn it into a mixed number?
We could change it back into an improper fraction, into a mixed fraction, or I'm going to be fine if you leave it as either one. Sometimes in a question I'll say, write your answer as a mixed fraction, then you have to change it at the end. Okay? But I'll be clear when I do that. So now, these numbers are getting big, but of course now we're dealing with, you have a calculator. This part is showing your work, so I go back to my calculator, I'm like, what is 16 times 4?
Wait, would it be negative 16?
64?
Oh, right. Well, let me do 16 times 4, and then I get 64.
So it'd be
Awesome.
Would it be negative 64?
But because it's negative 16 times 4, I would get a negative 64. Timesing by 11 is actually pretty easy. 55. And it's a negative 55.
Oh, it'll just be negative.
And what happens when you have a negative divided by a negative?
Positive.
It's positive. So this is the same as positive 64 over 55. Does that match up with what we wanted? Right, then we draw one of these. Oh. Yeah. Notes. Lunchtime. Or during break. Do you think you'll be able to wait to break?
Yeah.
Awesome. So that's all I wanted to do for multiplying and dividing. I have a sheet that I'm going to get you to hand in, but I'm thinking 20 minutes is going to be enough. So I'm going to give it to you with 20 minutes left in class. Yes.
Just do it by yourselves.
You can work together, and then use your calculators. I like it when people are working together and talking about math. Yeah, I like that. Okay. So now I'm going to get you to skip ahead to the bottom of page 38. Actually, I'll get you to turn to page 39. This is on page 39. This is the last topic of our unit. Then I'm going to put together a practice test for you and a test that's going to have all the stuff in this booklet together. And then we get started a new booklet.
Will the test be next week probably?
Yeah. Test will be next week. Because it's all well. Yeah, let's do this. The last idea that we're looking at is square roots. In mathematics, we have this as a symbol for square roots. That button is on your calculator. Does anybody know what this is equal to?
3.
It's equal to 3. 39. 39. Sí, 38. Aquí estamos. 39.
Wait, how do you figure the square root? I didn't forget.
So how you figure out a square root? When you're looking for a square root, you are actually thinking this. What number goes in the space? Whatever goes in the first space has to go in the second space. 3. Because 3 times 3 equals 9. Perfect. Okay. All right. How about this one?
6 times 6.
6 times 6 is 36, right?
Mm-hmm.
All right. How big? Wait. You still got this?
10.
Jeez.
Yes.
That is good. Okay, I'm going to go higher then. See when you, how about this one? Does anybody know this one?
12.
Okay. All right, how? I'm going to go to one, I'm going to go bigger. How big did I think? There we go. That should stop.
25.
25. Is that impressive? Wow. Okay, smarty pants.
You like start with like 9 or something. Started with 9.
Started with a 9. Okay.
Ready?
30. Ooh. I got one for you. That I think will stump you at the beginning, but when you see it, you're going to get it.
So you're gonna
Anybody have an answer? Stumped you a little bit? Oh yeah, I think I got a little bit, I got you stumped. You didn't get stumped on the 900. Someone got the 625, but now,
I might not even know if, can I try?
yeah,
Is it just the square root of
No,
2/3?
because this is what you're looking for. Something times something has to equal 4/9. And Mr. Shirk is right.
2/3?
Because if you had a 2 and a 3 and a 2 and a 3, would they not be the same number? And fractions, you multiply the tops, you multiply the bottoms? Oh.
That was a good one.
Okay, now if I do another one.
4/9. 6
Close.
times.
6/7. There we go. I'd like to think I did that on purpose, but no, it just happened.
Sure.
We don't know you don't.
I did it on purpose. Okay, so that's what a square root is. It's looking for the number that times by itself is equal to what was inside the square root sign. So in our notes, what do we got? A number that is the product of two equal rational factors is called a perfect square. So number 9 is a perfect square because it's a 3 times 3. What do we have? 4/9 is a perfect square because it's 2/3 times 2/3. If something is something times something, we call it a perfect square. Usually we leave perfect squares, we like perfect square whole numbers. So you get like 1, 4, 9. What's the next one? I'm looking at perfect squares. 1 is the first in whole numbers. 1 is the first one. 4 is the second one. 9 is the third one. Does anyone know what the fourth one is?
25.
No, 25 is the fifth one.
Is it lower?
16.
16 is the fourth one. 25 is the fifth one. Does anyone know what the sixth one is?
36.
36. Then the seventh one? 49. So those are called perfect squares. And the reason they're called perfect squares, here's the list of them. Okay. We did that symbol already. Oh, we got some math first, and then we'll talk about a graphic why something's a perfect square. Okay, here's 2 more mental math. Can you figure out? 9. Excellent. And 15. Impressive. Now, let's say you didn't know it was 15 and you had your calculator. What we got to find on our calculator is that button. And on my calculator, it's like hidden a little bit. You see how it's here in blue? So I actually have to hit the second and then this to get it. And I can write square root of 225. Check if Igor was right when he said 15. Oh, he was. So we have that button on the calculator. You should be taking out your calculator and looking, where is that button on your calculator? Can you type that in and get 15 as well? Okay. Now, technically, if I put this as a question for you, 64 equals what times what, there's actually 2 possibilities. It could be 8 times 8, but it could also be -8 times -8, because a negative times a negative is a positive. But when we use this symbol, and I'm going to highlight this here, whenever we use this, the answer if we use that symbol, we are only going to look for the positive one. If we want the negative one, we have to put a negative in front of the square root. Okay, 4 more for you to try.
Mr. Gayor?
You got them?
Yeah, it's just now I didn't know what you wanted from me. So I-
You wanted to put other because there's 10 questions on each page, and then I'll figure the thing on 5 after.
And then if I put it at a 10 on each side, right?
Yeah, I'll figure out what I want to do on 5.
Then if it's just like, it'd be 9, it's
So we got 1.
1.
Yeah. Perfect. Okay. Can you do the square root of 1? Is something times something 1? 1 times 1 is 1. So the square root of 1 is 1. What are we going to do with that negative out in front? Just keep it out in front. The answer for this one is negative 1. Uh-oh.
20.
20.
Yes.
Oh, you're right.
20. 2,500. It's 50. And then the last one's a little bit crazy.
7.
No. I'm gonna let you guess for a while.
Negative 7.
No. Keep guessing.
What?
The last one's tricky. It's not 7. It's not negative 7.
Negative 49.
It's not negative 49. So you get stuck, so you go out and you try your calculator.
8.
What does your calculator say? Because so far your guessing's been terrible.
Are we off by a lot?
You're off by a lot, yes. What is the calculator? Nobody has their calculator. Anybody trying it?
Is it 23?
It's not 23. It's 967. No.
Is it a positive number?
80.
Not
80 yan.
No, it's not 80. What happens when you push enter?
No,
All right.
49?
Negatibo.
What did your calculator say?
Is it 12?
Hmm? Error.
So it's
His
not possible.
calculator says math error.
So it's not possible?
It is not. The answer to this one is not possible. That's what you'd have to write on a test. It is not possible. Why is it not possible? This is how we think of it. If I have this, I am asking you this question. Negative 49 is equal to something times something. And both of these things in these blue circles have to be identical. So they're either two positive numbers or two negative numbers.
So why doesn't say word?
So if you did 7 times 7, what do you get? Positive 49. What do I want?
What if you
Negative 49.
If you do one negative.
But they have to be exactly the same.
Oh.
If you did both of them negative,
Yeah, but you tell us positive.
it'd be positive again.
I didn't see it.
2 positives.
So anytime you have a square root of a negative, there are some things in mathematics that are not allowed. Square rooting negative numbers is not allowed.
Does it?
Unless, like in higher level math, they have some numbers called imaginary numbers. I'm not making this up. This is true. There are imaginary numbers. Our numbers that we looked at were called the real numbers. If you want to include imaginary numbers, then you can do this math. But that's higher level math that we're not going to get to. But you can see on my, I don't know if you've ever seen over here, I've got a little comic on the board over here that has a square root of negative 1. And the guy is arguing, get real. Because the square root of negative 1 is not a real number. It does not exist. We write not possible. Yes?
Wait, don't 2 positives equal a negative, right?
2 positives are 2 times 3 is negative 6? Nuh-uh.
No.
No.
I just forgot.
I know, it's so easy. We learn so many rules. Sometimes if you're thinking of a rule, double check the rule with easy numbers that you know. Like if you're like, isn't a positive times a positive negative? And you're like, so you're telling me 2 times 3 is negative 6? And you'd be like, no.
We got some no-namers.
Okay.
We
You
got
want to,
s- We got some no-namers, we got some,
oh, okay. Do you want to
quite
take,
a
do you want to take the no-name ones and just walk around and see if anybody recognizes the writing? All right. Perfect squares. Now we're going to go to fractions and decimals. We got, okay, at 2 o'clock I'm going to give you your assignment to work on, so we got a couple more minutes. Are these perfect squares? 8 over 18, 16 over 5, 2 over 9, 6.25, and 0.627. If you have a calculator, this is what you could do. You could take out your calculator and you could use your square root button. And the first one that I have was 8 over 18.
no.
Is this going to work out to a nice number? Then it's a perfect square. If it is not, then we have trouble. I push enter. It does work out perfectly to 2 over 3. So I go back to my notes. And I write under A, yes, 2 over 3. Since I can show my work, 2 over 3 times 2 over 3 equals, that is a 3.
Is that you?
How do you multiply fractions? Multiply the tops, 4, multiply the bottoms, 9. But I have 8 over 18.
It's 2.
Why is it 4 over 9?
But I don't think that's right either.
Because divided by 2.
Yes, look at that. This one you could have divided by 2, and then you would get 4 over 9. And maybe if we had started with 4 over 9, some of you would have saying, yes, it's 2 over 3 times 2 over 3. What about B? 16 over 5. It's already reduced.
Hey, you get the right idea. You just
This one is no.
5.
Why?
adding on.
Because if I go to my calculator first,
Trying to get one meter now.
and I do
We'll be able to sort through what's going on.
square root,
But like a lot of these are also reduced, so you got to have all those.
if I do this on my calculator, if it is nice, it'll come up with a nice number. If it is not nice, it'll give you a decimal that keeps on going.
Yeah, look at it. 7 minus 4 is 3.
If I think of it,
Okay.
for 16 over 5, it looks like it's really close to being nice. Can you see the tops of my fractions? Could be 4 times 4. That makes 16. But 5 is not... 5 doesn't work out nice. Because 2 times 2 is 4, and 3 times 3 is 9. 5 doesn't work out nicely. Okay, what about C? 2 over 9. Can you see the bottom would be nice? 3 times 3? What about the top?
Could that be all?
No.
So we gotta know that.
If you get to decimals, let's check on our calculator. With a decimal, if it comes out to a nice decimal that ends, then it's going to be a perfect square. If it keeps on going like the last one, it isn't. So I'm going to go back to my calculator. I'm going to use my square root button, and I'm going to write 6.25. Is it nice? Yes. So I can write here, I'm going to write yes, and I figured it out with my calculator. 2.5 times 2.5 nicely works out to 6.25. And we have one more. E is 0.627. So I'm going to test out 0.627 on my calculator. And you should be checking it as well with your calculator. 0.627. Does it look like it keeps on going? Yes. So, for that one, the answer will be no. Maybe I put in brackets, not a decimal that ends or terminates. So 2.5, nicely, that decimal ended. That makes it a yes. But if it keeps on going, that makes it a no.